So on example 3 here, I'm going to hand out some scrap paper. Start a pile here, I'll start a pile here, start a pile there, start some there, I'll pick up the extras. Take 3 pieces each. Yeah, because you're going to have at least 3 graphs that we're going to do. And so what I would like you to do for this one is I want you to sketch log 2 of 2x minus 1 on your paper. We'll do this whole question, we'll do the table of values and the sketch, but I want you to try to sketch using transformations that graph first. What's that? I think there's enough that it'll kind of come down and then come back up around. Good. So in A, creating a table of values, well, first of all, you should know that your log 2 graph looks like this. Every log graph has the point 1, comma 0. Since the base is 2, this one's going to have the point 2, comma 1. So as far as a table of values go, we already know when x is 1, y is 0. When x is 2, y is 1. Which other points that are nice do we know on this graph? 3? 3's not. 4. 4 is a nicer number, right? Because if you put 4 in for x, 2 to what power is 4? 2. Another nice one? 8. If you put in 8 for x, you're really asking 2 to what power is 8? It's going to be 3. And if we put a not nice number in? Well, even a regular number that ends up not being nice in the end, like 3, because someone said they wanted to do 3, the best you could do is write log 2 of 3. But that's not a very helpful value. You'd have to go to your calculator to figure that out. But the other ones we could do by hand. And we know what the parent graph looks like. We know that our log base 2 of x graph has the point 1, 0, it has 2, 1, and it has an asymptote at x equals 0. And so if we want to do these transformations, if we want to graph log base 2 of 2x minus 1, the first thing, and sometimes people even take a highlighter out and do this, is they highlight that 2 because that 2 is part of your parent graph. It is not a transformation. So by highlighting it, you're reminding yourself, I don't have to worry about that when I go from left to right. When I go from left to right, the first number that I run into is this 2, and that's going to be, since it's inside the function, horizontal, it's going to be a horizontal compression. You're going to multiply your x values, right, by the reciprocal, by 1/2. Is that minus 1 inside the function? No. If they wanted that minus 1 inside the function, they would need to put brackets to indicate that it was inside the log. So this minus 1 is going to be vertical. It's going to be a vertical translation 1 unit down. So just like we did in our first chapter in chapter 3, we would take our points 2, 1, 1, 0, and our asymptote x equals 0. We would go through all of our stretches and compressions first. We only have the one compression. We're going to multiply x by 1/2. So writing that above tells us, okay, now I'm going to have 1, 1 and 1/2, 0. And then we do our translations. We only have one translation, so it's going to be 1 down. Now, our vertical asymptote, which is at x equals 0, the only way it's going to be affected is if you translate it left or right. All of the other transformations don't affect it. And since we're not translating anything left or right, it's going to stay at x equals 0. So when we go to our graph, I always like to start by graphing my asymptote. So I know there's my asymptote at x equals 0. I can plug my points in. We have one point at 1, 0, and the other point at 1/2, -1. Draw the shape of your log graph, and you're done. So on your scrap piece of paper, here is your second graph. What we're going to do is we're going to eventually put this second graph on, I think page 400 is a blank page in your notes, but we're going to graph. So try it first on your paper. If you're confident, you can copy it down into your book. Y equals 4 log base 3 of x plus 1 minus 5. So first of all, off to the side, we'd recognize that the parent graph is log base 3 of x. So log base 3 of x would have an asymptote here at x equals 0. It would have the basic shape of all log graphs. It would go through 1, 0 and 3, 1. We take out our highlighter. We remind ourselves that that 3 is part of our parent graph. So that's not going to be involved in our transformations. If you like to label things as you go, this is going to be a vertical stretch. You're going to multiply y by 4. Here you're going to move 1 to the left. That's a horizontal translation. And here we've got a vertical translation, 5 down. So we could take our original points, 1, 0, 3, 1, and our asymptote at x equals 0. Move from left and right. Do all your stretches compressions first. You only have the 1, which is y by 4. So we still have 1, 0, and now we have 3, 4. And then we do our translations, which we have 2. We're going to go 1 to the left and 5 down. And when we think about our asymptote, again, the only thing that's going to affect your vertical asymptote is if you move things left and right. We are moving left 1, so our asymptote becomes x equals -1. So to sketch our graph, starting with the asymptote, x equals -1. And I'd actually encourage you, if you have a red pen, to have a red pen for all of your log graphs and all of your exponential graphs, and always draw your asymptotes in red pen dotted. Because sometimes, and I saw this on the quiz, sometimes on the y-axis, it's hard to see if you do pencil over top of it. And it is a half a mark deduction if you don't draw an asymptote on an exponential or a logarithmic graph. So you need to have it drawn on there because it shows that you know that the graph approaches that line but doesn't pass it. Now we can plot our other points. We've got 0, -5, and 2, -1. So there's our final graph. Okay, your last scrap piece of paper, the hardest one so far. Graph y equals 2 natural log of 1/2 x plus 2 minus 3. So first of all, what's the base and what's the parent graph? The natural log of x. So the parent graph, again, like all log graphs, it's going to have 1, 0. It's going to have this shape. It's going to have an asymptote at x equals 0. The point on this one is going to be e, 1. So the base of the natural log is the number e, which is approximately 2.7. So there's our parent graph. Now we want to graph y equals 2 natural log. But before we graph this, you see how we have a horizontal stretch and a horizontal translation? So we have to factor that out. So now factoring that out, factoring the half out of x, people are pretty good at that because that's what they have to factor out. But it's the next number that people have trouble with, especially when there's a fraction out front. So the best way that I found to figure this out is you start by writing it like this. And you think, well, this makes sense because a half times x, that'll give me a half x. What would have to be here so when I go a half times that, I get 2? 4. And if you think that way, I find it's easier to factor out those fraction ones. Sort of think backwards. What would I have to multiply to get 2 so that it works? Oh, I can see that it's going to be a 4. And then we still have a minus 3 at the end. So going through these from left to right, well, this is going to be a vertical stretch. Your y values get multiplied by 2. Here we have a horizontal stretch. Our x values get multiplied by 2. Horizontal translation, 4 to the left, and a vertical translation, 3 down. So just like all of our other transformations, we're going to start with our beginning points. We have 1, 0, and we have e, 1. Our asymptote is at x equals 0. All of our stretches and compressions, we have 2. We're multiplying y by 2, and we're multiplying x by 2. So this point will become 2, 0. This point, multiplying the x by 2, you'll just write 2e, and multiplying 1 by 2, you'll get 2. Our next set of transformations are our translations. So we're going to be going 4 to the left and 3 down. This will get us at -2, -3. And here, the best we can do is go 2e minus 4. If we want to leave that as an exact value, that's going 4 to the left. 3 down, we'll end up at -1. As far as where our asymptote will go, again, the only thing that affects our asymptote is moving things left or right. And in this case, we're moving things 4 to the left. So our asymptote will be at -4. X equals -4. We can now take this information, put it on our graph, starting with our asymptote. There it is at x equals -4. Starting with the easy point, -2, -3. Now, if e is about 2.7, 2 times 2.7 is 5.4, minus 4 is going to be 1.4. So I need to label a point at about 1.4, -1. Again, when I label it, I'll label it with its exact value. But as far as estimating where that point should be, that's how you can do that.
Shouldn't it be -1?
Yeah, it's going down, but the 2e is 5.7 minus 4 is positive 1.4. And now if we connect those points and get the shape of our log graph, this is what it would look like. Okay, out of your homework, practice ones, 8, 9, 10, and 11,